Hi, I'm going to talk a little bit today about the scale of the solar system, and as I do that I will have to think about what do I mean. First of all, we could have the scale of the sizes of the objects, and second, we could have the scale of the distances from the sun. And if we try to put those both together at the same time, we have a difficulty, because if you imagine looking at the solar system from far away, outside of it, you could look and see where the planets were, but you wouldn't be able to see the individual planets in much detail to compare the sizes. So first of all, we'll just imagine that we look at all the planets up fairly nearby and see what they look like and compare the sizes. Then we'll look at the comparison of the distances. So first of all, we have the two types of planets, and we'll begin with Jupiter right here, the largest, and work our way down. Saturn is the second largest. Notice it has the rings. We can see the Cassini division. And these are the gas giant planets. Then we have Uranus and Neptune. These are called water or ice giant planets. Or sometimes just these four are grouped together and called the giant planets. As we see, all of them are significantly larger than Earth. We have the planets that are the terrestrial planets. Rocky planets are Earth-like planets, and the largest is the Earth, the third planet. The next largest is Venus, which is only slightly smaller, about 90% the size of Earth. Then we have Mars, a lot smaller than the Earth, and finally Mercury, which is also a lot smaller than the Earth. We can see that in comparison to the diameter of the Sun does not fit on this scale. The Sun would be much larger, as shown here, going off the scale. And Pluto is much smaller than any of the planets. Pluto here is considered a dwarf planet. The other 8 are planets. Now, if we do want to look at how this compares to the Sun, we can put the Sun on the same scale, where we have the entire diameter of the Sun. But if we do that, then Mercury, Venus, Earth, and Mars become hardly visible here, and Jupiter, Saturn, Uranus, and Neptune we can see, but they are significantly smaller. So it's difficult to see the small planets and the Sun on the same scale. We also have here the scale of the distance in this diagram, showing the inner planets are quite close to the Sun and the outer planets are spaced much further out. If we look at a direct comparison of 3 major objects in the solar system, the Sun, Jupiter, and the Earth, we can see that the Sun is much bigger than Jupiter, which is also then much bigger than the Earth, but it allows us to compare that. The Sun is about 10 times the diameter of Jupiter. We can see here about 10 Jupiters cross the diameter of the Sun. Jupiter is about, the diameter of Jupiter is about 11 times that of the Earth. We can see it takes about 11 Earths to cross one diameter of Jupiter. The great red spot on Jupiter is a little bit larger than 1 Earth diameter. And the moon, compared to the Earth, The diameter of the Earth is about 4 times the diameter of the Moon. We can see in this picture, maybe slightly less, 3 3/4. It would be a little bit closer. So there's a large range in differences between various objects in the solar system, going from the Sun, Jupiter, Earth, and then the Moon. If we look at some objects in the solar system, this is a selection, some are not here, that are a little bit smaller than the Earth, but still pretty large objects compared to many smaller ones. So the planet Venus is not here, but Earth is there, and Mars is significantly smaller than Earth, you can see. And we have some moons. Titan is here, and we can see that it is has a gaseous appearance because it has an atmosphere. Is a little bit larger than Mercury, which is a planet. Titan is a moon of Saturn. Mercury is here, the smallest planet. Our own moon is a little bit smaller than Mercury, about 2/3 the diameter of Mercury, and about half the diameter of Mercury is Pluto. And so Pluto is a dwarf planet, and we see that it is smaller than several of the moons in the solar system. In fact, there are 7 moons in total that are all larger than Pluto. If we look at this montage of pictures of moons in the solar system, I want to keep in mind that in some of these pictures, the moon actually is round. It's just a picture that has kind of a gibbous phase to it, where it looks like it's not completely fully lit, but that's just the angle of the photograph. Virtually all of these are very round, except Hyperion, a very small object there. So all of the larger objects are really very round. And we want to look at the Earth here is just given as an example for size and comparison to scale. I want to think about the moons in the solar system as belonging to 3 groups. The large moons, and there's 7 large moons. Starting from largest to smallest, the 7 large moons are Ganymede, moon of Jupiter; Titan, again we can see the atmosphere, moon of Saturn; Callisto, another moon of Jupiter; Io or Io, moon of Jupiter; and our own moon; and then Europa; and finally number 7, Triton, are the 7 large moons of the solar system. And each of these are very unique objects. They're quite a wide range of phenomenon associated with them. So they are large enough, they're all very round, they're large enough all to be round. They would be large enough to be planets in their own right in some cases. The moons here, Ganymede and Titan, are both larger than Mercury, although Mercury is more massive. It's a very dense planet, so it is more massive, but smaller than Ganymede and Titan. So the next group of moons are the following. The medium-sized moons are Rhea and Charon, Pluto's moon, Rhea, and is Saturn's moon Iapetus, Dione, Tethys, Enceladus, Titania, Oberon. These are Uranus's moons, Ariel, Umbriel, and Miranda. All of those are considered. And then Nereid, moon of Neptune, maybe are the group of medium-sized moons. So these are not just small rocks, they are definitely worlds in their own right, very interesting objects. But they don't fulfill the class of the large moons, which are much more dynamic and show a diverse range of features. So, if we then look and concentrate on the distances, imagine that we take the planets and we're looking at the solar system from the side, and we have a scale here that we can keep track of, but we've blown up the planets about 1,000 times in their true sizes to represent them here by these dots. We see that by definition we have 1 AU, 1 astronomical unit, is the average distance from the Earth to the Sun. And so that's measured here on this graph is where the Earth is. And if we go out to 10 astronomical units, this is out about where Saturn is. Uranus is a little bit less than 20 astronomical units. Neptune is almost 30 astronomical units. Pluto has a wide range. It goes all the way from Neptune's orbit well out beyond 40 astronomical units and even further.